Hello everyone, I'm Dr. Jamal Javanmardi
And I'm Alexander Luna.
and we are going to demonstrate how to grow mushrooms. By the end of this video, you will understand the science, technology and decisions behind the successful mushroom production. Welcome to the teaching module on mushroom production. I'm Dr. Jamal Javanmardi, a professor of vegetable crop physiology and production at Chico State University. I'm very excited to guide you through the fascinating world of mushrooms and the incredible intersection of biology, sustainability, and agricultural innovation. In this presentation, we will explore how mushrooms grow, how they are cultivated, and why they have become such an important part of the global food system. By the end of this, you will see that mushrooms aren't just food. They are a cornerstone of regenerative agriculture. To start, let's appreciate the diversity of mushrooms. There are more than 10,000 edible mushroom species known to the science. Despite this diversity, one species dominates the global market, the white bottom mushroom, representing around 65% of global production. It's easy to cultivate, has a mild flavor, and integrates beautifully into countless cuisines. But mushrooms aren't just delicious, they are nutritional powerhouses. They contain high-quality proteins, essential B vitamins, and antioxidants. That makes them a perfect food for modern diets emphasizing wellness and sustainability. We are out here at the farmers market in Chico, California. Most people are familiar with the classic white bottom mushroom, but today we are checking out some other varieties you don't usually see in a regular grocery store. Let's go. Mushroom Adventures. Hello, Dan. Yeah, I'm Jamal. How are you? Good to meet you. So, yeah, I'm recording a video. Is that okay with you? Yeah. Okay, you have very beautiful mushrooms.
I know. It's a lot of different kinds.
You have a variety of mushrooms, and would you tell us what kind of mushrooms you have here?
Oh my God.
Starting from here.
Okay, we have the lion's mane, and then this is called maitake or hen of the woods. And then this one is called cinnamon cap or chestnut mushroom. And then over there we have the black pearl. And then that one up front there is called a pulmonarius oyster. And then we have combinations here with trays with 2 or 3 kinds of mushrooms in each tray. Shiitakes and some other stuff.
When you make your super creamy stuff.
That's wonderful. So, what exactly are white bottom mushrooms? Their scientific name is Agaricus bisporus, and they are the most cultivated mushroom species worldwide. From spore to harvest, the life cycle takes roughly 40 to 50 days. These mushrooms are incredibly versatile, used not only in cooking, but also in health supplements and nutraceuticals. That's because their bioactive compounds help boost immune health and reduce oxidative stress. So the humble white bottom mushroom is much more than a topping. It's a biotechnological marvel. Now let's take a structured look at mushroom cultivation process. This is a controlled multi-phase system designed to optimize microbial and fungal growth. The major steps are compost preparation, pasteurization, spawn inoculation, casing, rooting, harvesting, and finally packaging and distribution. Each step has a distinct biological purpose, and precision at every stage ensures high yields and disease-free crops. The first phase is compost preparation, which is the foundation of mushroom farming. The common raw materials to be combined are wheat straw, animal or chicken manure, gypsum, and water in specific ratios. Through natural microbial decomposition, the mixture heats up to about 150 degrees Fahrenheit, helping break down complex carbon structures. This phase lasts 7 to 14 days, and by the end, the compost should be dark brown, moist, and emit a pleasant, earthy smell. This is when we know the compost is mature, rich in nutrients, and ready for the next phase. Again, the raw materials are wheat straw, soaked in water, then mixed with animal or chicken manure and gypsum. Sometimes, if the nitrogen level in the mixture is insufficient, you may add urea fertilizer to adjust the carbon to nitrogen ratio. In commercial scale, the wheat straw is soaked first by sprinklers or in specialized ponds. Then you need to mix them in proper proportions. Usually for every 1 ton of wheat straw, you need to soak it in 2,500 liters of water. Then mix it thoroughly with 600 kg of chicken manure, 60 kg of gypsum, 30 kg of molasses, and 10 to 15 kg of urea. Then you need to mix all the materials and make compost piles.
All right, here we are in the site of compost production for mushrooms. This is chicken manure, and we have straw bales that will be mixed together with the specific ratios to create compost.
So this machine is called bunker filler, and this machine is used to mix straw and chicken manure and gypsum together and back to the bunkers where the fermentation will be taking place for composting.
The piles are usually 7 by 7 feet in width by height, but the length depends on the amount of material. The piles are shaped by a compost turner. During the compost process, you need to keep the inside temperature around 65 degrees Celsius or 150 degrees Fahrenheit, and the moisture content of 70%. This is usually achieved by turning the compost and reshaping it again with a compost turner when the temperature goes above 150 Fahrenheit or 65 degrees Celsius. In the meantime, you may need to add water to the mixture.
So this is how it will look like after 5 days of mixing chicken, wheat straw and gypsum. And every 3 days we move this compost with these machines for the better mixing. So every 3 days, this compost is moved to add the water because compost lose the moisture. The temperature of the compost in the bunker stays between 100 60 to 175 degree Fahrenheit. So every 3 days it's moved, and compost stays here in this area. We call it phase 1 for approximate 14 days. So this is the computer system which handles our phase 1 compost, which explains that how much air and fan we're going to give to the compost for getting its best temperatures. So in phase 1, compost stays there for 14 days, and after 14 days compost goes to our tunnels, which we call phase 2 tunnels. This is where compost gets pasteurized and conditioned.
After about 7 to 14 days, depending on the operation, you have a compost ready for the next step. At this point, the compost is brown in color. You may not smell ammonia. The temperature should not be above 70 degrees Celsius or 158 degrees Fahrenheit. And for texture, it can be shared with moderate resistance. Next is pasteurization, a critical step to eliminate unwanted organisms. The compost is heated with pressurized steam to reach about 160 degrees Fahrenheit. This kills pests, molds, and harmful bacteria while preserving beneficial thermophilic microbes that stabilize the compost. Proper pasteurization also balances pH and nutrient composition, setting the stage for mycelium to thrive. To emphasize, a well-pasteurized compost should have a slightly sweet, earthy smell, not ammonia-like. For pasteurization, the compost is piled in the structures, and pressurized steam is injected into the pile from the bottom. The next phase is spawn inoculation. Once the compost cools after completion of pasteurization, it's time for spawn inoculation, or introducing the mushroom's living culture. Here are the brief steps of this phase. The spawn, which contains actively growing mycelium, is mixed evenly into the compost. The temperature and relative humidity must be carefully managed starting from this point. The mycelium spreads through the substrate through a process called colonization. By the end of this phase, you will see a white web-like network covering the surface, which is healthy mycelial growth. Now let's go into details. The spawn is actively growing mycelium that has developed on sterile grains such as wheat or millet. These are available in the market, and you need to mix them evenly into the pasteurized compost.
So this is the seed for mushrooms, and basically what it is, it's a millet grain, and then the mushroom fungus is grown on the top, and this will be we call it spawn. It will be mixed after the compost is pasteurized and conditioned and cooled down to 75 degree Fahrenheit, and then we add the seed to the compost. We call it spawning.
In the next step, the spawned compost is filled into bins, bags, or shells, depending on the operation. Whatever the operation is, you need to compact the compost to ensure good contact between the compost and the spawn. The compost should be about 8 inches or 20 centimeters in height and have a flat surface, as I am showing in these images. As I said, you may use bins, bags, compost blocks, or directly fill the shelves with about 8 inches of compost after compacting. The environment must be carefully managed at this point. The temperature is around 75 degrees Fahrenheit or 25 degrees Celsius. The humidity is high, about 95%, and carbon dioxide levels can reach 3000 ppm. This allows mycelia to grow. This picture is a small-scale mushroom production at Chico State University using plastic bins. Compare it with the next slide taken from a commercial production facility, Premier Mushroom, using a shelving system. As you noticed in both images, the substrate must be covered with plastic sheets to keep the humidity and carbon dioxide high in the substrate.
Yeah. So after the compost is conditioned and mixed with the seed, then compost is put in these shelves for 14 days. So for 14 days, just the roots for the mushroom grow in the compost. We call it mycelium.
What's a good temperature?
77 to 81 degree Fahrenheit. So as you can see, the spawn starts to grow in the compost, and it stays here for 14 days. After 14 days, peat moss is, we call it casing soil, which is mainly peat moss. Put it on the top of this compost to have mushrooms.
And it is necessary to cover the compost with the plastic.
Yes, right? So this is to retain the moisture in the compost. Okay. And you can start to see that these are the roots start to develop in the compost.
So the whitish
is, we call it mycelium, yeah. And it's growing in the compost. Okay. And those will be the food supply chains for mushrooms, right, from compost.
Okay.
After about 2 weeks, you will see a white web-like network covering the surface. That's a healthy mycelial growth, a process called colonization or spawn run.
So what do we have here?
So this is after 12 days. So 2 more days we're going to put the peat moss, which we call casing soil, on the top of it to have mushroom forming on top of casing soil. So here you can see all the blackish compost is turning into whitish, with all the roots are getting fully developed. We call it mycelium.
So these whitish beads are the seeds of the compost.
This is the seed. This is millet. So this is the seed which starts the mushroom mycelium in the compost. So in the first few days, it takes the food from the seed, but after that, mycelium starts to take the food from compost.
And you keep the temperature and
77 to 81.
Okay.
In the next phase, called casing, we apply a 1-inch thick casing layer, usually made from peat and estriol soil. This layer doesn't provide nutrition. It regulates moisture, gas exchange, and microbial balance. It also stimulates the mycelium to shift from vegetative growth to fruiting mode. This is a close-up image of a covered substrate with about 1 inch of casing soil. As you see, the thickness of casing soil must be even all through the surface. Within a few days, fine white threads will rise through the casing, creating ideal conditions for the next phase or pinhead formation.
So this is after the casing layer is put on, and as you can see now, that mycelium from the compost starts to run into the casing soil. Casing soil is peat moss and lime. So this is after 4 days of casing. And then maybe tomorrow we start, because still right now at this stage it's in a vegetative state, and then from tomorrow we will start changing into a fruitable stage by bringing more oxygen in, so that mushroom pins start to form on the casing soil. Yeah, so this is 7 days after casing. Right now you can see all the mycelium has come to the surface, and now we can start forming into a fruitable stage. So mushroom pins will start to form all over the casing soil now.
One of the most visually exciting stages is pinning, or the formation of mushroom primordia. These appear as tiny white dots across the surface, each capable of becoming a full mushroom. This phase is triggered by environmental changes, a drop in temperature, and increased fresh air exchange. Careful control is the key for this phase. Too dry or too humid, the pins may not develop properly. This is truly where biology meets art.
So this is 10 days after casing, and you can start to see small baby pins start to form in the casing soil. All these small pins, these are baby mushrooms which are forming.
Okay, this is the further stage of pinning and start of fruiting, right?
Yes. So now you can see pins are starting to form, and this is about 14 days after casing, 13-14 days after casing soil.
Okay, how do you manage changing from pinning to fruiting, or from a mycelium run to pinning and fruiting?
So in picking, we when we change to pinning stage, we lower the RH and the compost temperature and air temperature. We bring the air temperature down to 63, 64, and compost temperature to 70, and that starts the fruitification of the process.
The next phase is fruiting process. When conditions are optimal, the temperature is around 60 degrees Fahrenheit or 15.5 degrees Celsius, and the humidity is about 85%. The pins grow rapidly into mature mushrooms. Within just 7 days, they are ready for harvest. A single compost batch can produce 2 or 3 flushes of mushrooms, each slightly smaller than the previous but still marketable. This is a stunning example of biological efficiency and controlled growth.
So this is after 16 days of casing. These are mushrooms ready to be picked today, and we pick normally for 4 days once the mushrooms are there, and mushroom gain 20% of the weight every day.
The next phase is harvest and post-harvest handling. Harvesting must be done carefully. For premium quality, mushrooms are hand-picked, twisted gently from the substrate to preserve the mycelial bed for the next flush. For harvest, remember this rule: hold, twist, and pull. That's the technique for clean harvesting.
This is how they are picking, and these are crank or electric lorries which goes up and down, and then when the box is full they lower it down, and this is the first break. So after that 2 more breaks we will take from this room. So every room give us 3 times mushrooms. So after first break is finished, second break starts to come, and normally it takes about 7 days to start picking again on the second break.
Is there any differences between the first break and the second break?
Yes,
Yield and
the
quality?
yield is lower because compost food is getting lower with each break. That's why we only take 3 breaks, and after 3 breaks we sterilize the room and we bring the new compost in.
What about the quality of
Quality
Is
for
that
first break is better always. Second is quality is good. Third quality is also good because the number of mushrooms are getting less with each break.
This is the third break, right?
Yes, this is third break.
So after you harvest this, what do you do with the remaining compost?
Then we sterilize it by bringing the temperature to 160 degree Fahrenheit, and we sterilize the compost for 12 hours, and then we take the compost out, and that becomes organic manure for the farmers, so they take it from here and we bring the new compost in.
Regarding the management things, how much mushroom each labor can harvest per day or per hour?
It varies from each picker. Some pickers pick only 50 pounds, some pick 75. So it varies with each picker. Yeah.
55 pound or kilogram?
Pounds.
Pounds.
Immediately after harvest, mushrooms must be cooled to 34 degree Fahrenheit within 1 hour. This rapid cooling maintains texture, color, and nutritional quality. After harvesting, mushrooms are graded by size and quality, then packed in ventilated containers. Maintaining the cold chain from harvest to market is essential to prevent spoilage. Refrigerated trucks or cold rooms keep the temperature steady, ensuring mushrooms arrive crisp, fresh, and safe for consumers. It is worth mentioning that every hour outside the cold chain can reduce shelf life dramatically. So, precision logistics is key in this phase. Now let's talk about the market. The global mushroom market is growing rapidly, especially for organic and functional varieties. Demand for organic mushrooms has been increasing by about 25% each year. Why? Because of four major forces. First, the organic movement, as consumers seek sustainable food. Second, plant-based diet, where mushrooms replace meat. Third, the e-commerce boom, with nearly 20% of sales happening online. And finally, the functional food trend, where mushrooms are added to supplements and fortified foods. This growth means there is a huge potential for students like you to innovate in production, processing, and marketing. To summarize, mushrooms are far more than a specialty crop. They are a model for sustainable circular agriculture. They grow on agricultural waste, require little water, and provide high-quality nutrition with a minimal carbon footprint. The white bottom mushroom, Agaricus bisporus, continues to lead the way in this global movement. As future horticulturists and agricultural innovators, you have the opportunity to integrate mushroom production into broader systems of food security and sustainability. Let's keep exploring, keep experimenting, and continue pushing toward a future where farming is not just productive, but profoundly sustainable. All right. Thank you for watching, and remember, the future of agriculture might just be fungal.